Hello students, welcome to your channel Parivartan Physics. Today itself we have seen two videos. One is on 2 marks important numericals from electromagnetic induction and another one is from 2 marks important numericals from moving charges and magnetism. And many of you were commenting, were asking me to solve 5 marks numericals, right? See, I have already uploaded the videos on 5 marks numericals from electric charges and fields, current, electricity as well as alternating current. And in previous year I have uploaded first three chapters, alternating current, ray optics. All these I have already uploaded in the for the previous academic year, right? So they are very good questions. You can go through those videos also. You will get a very good grip on the numericals. In this video, in one shot video here, in this video we are going to cover 5 mark important numericals on electric charges and field as well as electric potential and capacitance. From these both chapters we'll see the 5 mark important numericals. But one thing is, in this video I'm not going to solve these numericals in detail. I will put the diagram, I will tell you the formulas which we have to use, I will tell you how to solve. Only thing what I will not do is I will not substitute the values and I will not go on simplifying the values and I will not keep the final answer here, right? So I will rest everything I will explain, right? So then only we can cover these two chapters in this video, right? Okay. ಆಮೇಲೆ ಈಗ ಇದ್ರೊಳಗೆ ಈ ವಿಡಿಯೋ ಒಳಗೆ ಏನು ನಾನು ನ್ಯೂಮರಿಕಲ್ಸ್ ತಗೊಂಡಿದ್ದೀನಲ್ಲ, ಈ ನ್ಯೂಮರಿಕಲ್ಸ್ ಗಳನ್ನ ಡೀಟೇಲ್ ಆಗಿ ಸಾಲ್ವ್ ಮಾಡಿದಂತ ವಿಡಿಯೋಸ್ ಆಲ್ರೆಡಿ ಅಪ್ಲೋಡ್ ಆಗಿದಾವ್ರಿ. ಆ ವಿಡಿಯೋಸ್ ಲಿಂಕ್ ಕೂಡ ನಾನು ನಿಮಗೆ ಡಿಸ್ಕ್ರಿಪ್ಷನ್ ಒಳಗೆ ಕೊಡ್ತೀನಿ, right? So if you want the detailed solution of these numericals, you can watch those videos. Okay, let us begin then without making any delay. Okay, the first question is, 2 point charges plus 15 microcoulomb and minus 10 microcoulomb are separated by a distance of 20 centimeter in air. Calculate the electric field at the midpoint of the line joining two charges. If a point charge of 20 millicoulomb is placed at the midpoint, what is the magnitude of electric force experienced by it? Okay, there are two charges here. First one is plus 15 microcoulomb and second one is minus 10 microcoulomb, right? They have been placed at a distance of 20 centimeter from each other, right? And what they are asking, calculate the electric field at the midpoint of the line joining the two charges. Let me say this is the midpoint. If this is midpoint, distance of plus 15 microcoulomb from the midpoint is 10 centimeter and distance of minus 10 microcoulomb is also 10 centimeter, right? We have to calculate how much is the electric field at this midpoint, right? Illi naಮಗೆ electric field ಎಷ್ಟು, that we have to calculate. That is the first thing. We have to calculate the electric field at the midpoint. This is the first thing we have to calculate. Second thing, if at this midpoint, if we place a charge called 20 microcoulomb, so 20 millicoulomb charge, if we place it at this point, how much force it will experience? We have to calculate this. So these are the two things we have to calculate in this numerical. See, very first thing what you have to do is, whenever the question is on electric field, you have to put the directions of the electric field at which point you want the net electric field. So first you mark the directions of the electric fields. How many electric fields will be here? There will be 2 electric fields. One is due to plus 15 microcoulomb, another one is due to minus 10 microcoulomb. We know very well, by positive charge, electric field will be away from the charge. By negative charge, electric field will be towards the charge. Okay, first let me mark the electric field of plus 15 microcoulomb. It has to be away from the charge because it is positive. So the electric field due to plus 15 microcoulomb will be in this direction. And I will name that electric field as E1. E1 is the electric field due to the first charge, that is plus 15 microcoulomb. And electric field due to the second charge, minus 10 microcoulomb. Electric field of negative charge should be towards the charge itself. So I will take the direction of electric field of minus 10 microcoulomb in this direction. Okay, so I will take this electric field as E2. So E1 is the electric field of plus 15 microcoulomb. E2 is the electric field of minus 10 microcoulomb. So there are 2 electric fields at that point. So the net electric field at the midpoint will be equal to the sum of these 2 electric fields. Why sum of these 2 electric fields? Because they both are in same direction. If they were in opposite direction, adana ನೀವು ಏನು ಮಾಡ್ಕೋಬೇಕಾಗ್ತದೆ, ಮೈನಸ್ ಮಾಡ್ಕೋಬೇಕಾಗ್ತದೆ. So what you have to do here, you have to first calculate the values of E1 and E2. E1 and E2 values ನೀವು calculate ಮಾಡ್ಕೋಬೇಕು. E1 and E2 values calculate ಮಾಡಬೇಕಾದ್ರೆ electric field of point charge formula use ಮಾಡಬೇಕು, that is 1 by 4 pi epsilon naught Q divided by R square. This formula we have to use. Okay, if you want to calculate E1, charge Q1, distance R. Okay, so to calculate E1, how much charge you have to take? Plus 15 microcoulomb. There is no necessity of taking the polarity of the charge in this formula. In electric force formula and in electric field formula, never ever use the polarities of the charges. ಅದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೂ ಕೂಡ -10 ಇದ್ರೂ ಕೂಡ ನೀವು 10 ಅಂತ ಹೇಳಿ ತಗೋಬೇಕಾ, +10 ಇದ್ರೂ ಕೂಡ ನೀವು 10 ಅಂತ ಹೇಳಿ ತಗೋಬೇಕು. ಯಾಕಂದ್ರೆ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ polarity we put the signs, we put the directions. Okay, so here Q1 means you should take 15 microcoulomb, micro means 10 to the power -6, R1 means you have to take the distance of that plus 15 microcoulomb charge. So from this point the distance is 10 centimeter, so you take it in meter, 10 into 10 to the power -2, you square it and you simplify it, you will get E1. Similarly E2 means again you have to use the same formula, that is 1 by 4 pi epsilon naught Q2 divided by R2 square. Q2 divided by R2 square. Q2 means you have to take 10 microcoulomb. Don't take it as minus here. Don't take minus. Take it 10 microcoulomb. 10 into 10 to the power -6 divided by R2 is again 10 centimeter. 10 centimeter you take it as 10 into 10 to the power -2 whole square. So you will simplify. You will get E1. You will simplify. You will get E2. Don't forget to write the units of the electric field. Newton per coulomb. Newton per coulomb. Okay, finally the net electric field at the midpoint will be equal to E1 plus E2, right? You will add these both, you will get the net electric field at the midpoint. That is the first question what we have been asked. Okay, this is the first one. Second one what they have told, if you place a charge of 20 millicoulomb at this point, e point or midpoint or 20 millicoulomb charge another place madre, how much force it will experience. So for that you have to use this formula. See, we know very well F is equal to force, F is equal to E into Q, right? We are using this formula because we already know how much is the electric field at this point. Net electric field at that point we already know. That's why we are using this formula. Okay, electric field is already known. You have calculated here. Substitute that electric field here. I mean electric field at the midpoint you substitute into the charge. How much is the charge? Charge is 20 millicoulomb. Right, you will multiply, you will get the force, right? The SI unit of force, that is Newton, right? This is how we have to solve this numerical, right? I guess you understood the detailed solution. All the things I have substituted, I have calculated, and final answer also I have calculated in that video. You can watch that video for the detailed solution. Okay, well, so this is how we are going to see the numericals in this video. Okay, we'll go to the next question then. Okay, the next question is point charges +1 microcoulomb +1. ಆಮೇಲೆ ನೋಡ್ರಿ ಇಲ್ಲೇನ ನ್ಯೂಮರಿಕಲ್ಸ್ ತಗೊಂಡಿದ್ದೀನಿ, ಇದಕ್ಕಿಂತನೂ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಲ್ಲಿ ಅದಾವ್ರಿ. ಇನ್ ದೋಸ್ ವಿಡಿಯೋಸ್ ದೇರ್ ಆರ್ ಸಮ್ ಮೋರ್ ನ್ಯೂಮರಿಕಲ್ಸ್ ಆಡೆಡ್ ಅದರ್ ದನ್ ದಿಸ್. ಇವು ಅದಾವ, ಇದ್ರ ಜೊತೆಗೆ ಮತ್ತೆ ಬೇರೆ ನ್ಯೂಮರಿಕಲ್ಸ್ ಕೂಡ ಅದಾವ. ಸೊ ಯು ಕ್ಯಾನ್ ವಾಚ್ ದಟ್. ಸಿಮಿಲರ್ ಅನ್ಸುವಂತವ ಅಥವಾ ಯಾವ್ದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಅಂತ ಅನ್ಸುತ್ತಲ್ಲ ಅದನ್ನ ಇಲ್ಲಿ ತಗೊಂಡಿಲ್ಲ. ವೆರೈಟಿ ಇರುವಂತವ್ ಮಾತ್ರ ಇಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ, ಆಲ್ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್. ಓಕೆ, ವೆಲ್, so point charges +1 microcoulomb, +1 microcoulomb and -1 microcoulomb are placed at corners A, B, C of an equilateral triangle ABC of side 0.3 meter. Calculate resultant force on charge at point B. Okay, let me call this point as A, this point as B, this point as B, and this point as C. Okay, at point A the charge is +1 microcoulomb. At point B the charge is +1 microcoulomb, +1 microcoulomb, and at point C the charge is -1 microcoulomb. Correct? And what we have to do now, side of the triangle is 0.3 meter. Okay, it is an equilateral triangle, right? It is an equilateral triangle, so all sides will be same, 0.3 meter, 0.3 meter. Okay, next we have to calculate the electric field at point B now, right? So to calculate the electric field at point B, you first decide how many electric fields are there at point B. What they have called, sorry, not electric field, they are asking us calculate resultant force on charge at point B. Okay, so the resultant force on this charge, on charge which is placed at B. So B point alli iruvanta charge mele ಎಷ್ಟು forces act aglik sadhyade. One is due to the charge at A, one is due to the charge at C. So two forces will be acting on this charge which is at B, because on any charge how many forces will be acting, how many charges are there in its surrounding, ಅದರ surrounding ಒಳಗೆ ಎಷ್ಟು charges ಅದಾವ ಅಷ್ಟು forces ಅದರ ಮೇಲೆ act ಆಗ್ತಿರ್ತಾವೆ, right? Okay, ಈಗ ನೋಡ್ರಿ ಈ B ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇರುವಂತ +1 microcoulomb charge ಮೇಲೆ there will be a force acting due to the +1 microcoulomb charge which is at A, and there will be a force acting on this due to the -1 microcoulomb charge which is at C. Only thing is, since these both are positive, the force between them will be repulsive. Since these both are opposite in sign, the force between them will be attractive. So force acting on +1 microcoulomb due to +1 microcoulomb at A will be repulsive, and I have to show it in this direction. It will be repulsive and I have to show it in this direction. Clear? So this is the force acting, on charge at B. This is the force acting on charge at B due to the charge at A. I will call this as F1. F1 is the force acting on charge B due to the charge A. Similarly, the force acting on charge B due to charge C will be attractive. That's why that force will be acting in this direction. That force will be acting in this direction, right? I will call this force as F2. I will call this force as F2. So finally, we got to know on charge at B, there are two forces, F1 and F2. Now we have to find the result of these two forces. Okay, first you find out the angle between these two forces. Since this is equilateral triangle, each angle will be of 60 degree. This is 60 degree. How much will be this angle? How much will be this angle? Since this is a straight line, how much will be this angle? This will be 180 degree, right? 180 degree. If this is 180 degree, out of 180 degree, if I remove 60, how much will be this angle? This will be 120 degree, right? So this angle will be 120 degree. This is 120 degree. After knowing the angle, then only you can find out the resultant force. Okay, first what you do, you find out the values of F1 and F2. F1 is the force between +1 microcoulomb and +1 microcoulomb only. F2 is the force between +1 microcoulomb and -1 microcoulomb. Correct? So like this, we are having, it means only polarity is different. So this is also 1 micro, 1 micro, this is also 1 micro, 1 micro. It means the charges are same and the distance is also same. Distance between AB is 0.3, distance between BC is also 0.3. Since charges and distances are same, these both forces will be same. F1 and F2 will be same. Correct? So F1 equal to F2 equal to, I will write it like this, F1 equal to F2 is equal to, since both are equal. Why both are equal? How we got to know? Since both the charges are equal, 1 micro, 1 micro, 1 micro, 1 micro. Distance is same, 0.3 meter, 0.3 meter. That's why both forces are same. So apply the formula. Don't forget to write the formula at any cost. First you write the formula and then make the substitution, and as much as possible go in detail. Solve each and every step in detail, right? Because it carries 5 marks, hence you have to go through. Even if you know any shortcuts, don't use them, go in detail only, right? It is far better for you. Okay, so F1 and F2 will calculate, we'll substitute. Q1 means 1 micro, Q2 means 1 micro, distance 0.3, all that we will substitute, and we will get the force here. F1, F2 values we will get, right? Okay, now these both F1 and F2 are acting at an angle 120 degree in between them. So this is F2, this is F2, and this is F1. This is F1. Angle between them is 120 degree. Angle between them is 120 degree. Since both the forces are equal, and angle between both the forces is 120 degree, the resultant force will be equal to any one of the force. Resultant force will be equal to any one of the force. This we know by vector. So instead of that, what you do, you better apply the formula and solve, because this is a 5-mark question. Even we know the result, we'll solve it like this. F is equal to root of F1 square plus F2 square plus 2F1 into F2 into cos 120 degree into cos 120 degree. Cos 120 degree is minus 1 by 2. See, it will be like this. Now F is equal to, this is F1 square. F2 means I will take it as F1 square only, because they both are equal. F1 into F2, I will take it as F1 into F1. F1 into F1, it will be 2F1 square into minus 1 by 2. Correct? Cos 120 degrees minus 1 by 2. 2 and 2 will get cancelled. I will get it as F is equal to root of 2F1 square minus F1 square. F1 square plus F1 square, 2F1 square. 2F1 square minus F1 square will be F1 square. So root of F1 square, square root and square will get cancelled. So this will be F1, right? So this is how we have to calculate it. Okay, we'll go to the next question then. So the next question is, 3 charges each equal to plus 4 nanocoulomb are placed at 3 corners of a square of side 2 centimeter. Okay. Find the electric field at the 4th corner. Find the electric field at the 4th corner. Okay. So we'll take a square now. We'll take a square. So this is the square, right? Okay. So this is the square, and they have placed plus 4 nanocoulomb at 3 corners of the square. Plus 4 nanocoulomb, plus 4 nanocoulomb, and plus 4 nanocoulomb at the 3 corners of the square, whose side is 2 centimeter. 2 centimeter. Since it is a square, all the sides will be same, right? You have to draw the relevant diagram like this. Okay, what they're asking, find the electric field at the fourth corner. How much is the electric field here? This is what you have to calculate. See, how many charges are there? There are 3 charges. Then there has to be 3 electric fields. Since there are 1, 2, 3 charges, there has to be 3 electric fields. Okay, first let me draw the diagonal here. Okay, so this is the diagonal. Okay, next we'll now mark the directions of the electric fields. Okay, electric field due to plus 4 nanocoulomb has to be away from the charge. So I will take it in this direction. This is the first electric field, right? I will name that electric field as E1. This is the electric field due to this charge. Another electric field due to this charge has to be out away from the charge. So it will be along the diagonal like this, right? Along the diagonal like this. And I will name this electric field as E2. I will name this electric field as E2. Another electric field is due to plus 4 nanocoulomb again. Since this is positive plus 4 nanocoulomb charge, again the electric field due to this charge has to be away. So this will be in this direction. Okay, well, I will call this electric field as E3. So how many electric fields are there at the fourth corner? There are 3 electric fields. Okay, now we have to find out the resultant of all these 3. Since there are 3 electric fields, which 2 electric fields will be equal? You can get it now. See, if the charge and distance is same, electric field will be same, because we know electric field of a point charge is given by E is equal to 1 by 4 pi epsilon naught Q divided by R square. Correct? Here, if you check E1 is the electric field due to plus 4 nanocoulomb whose distance is 2 centimeter. E3 is the electric field due to plus 4 nanocoulomb whose distance is 2 centimeter. Correct? So charges are same, distance is same. Hence, E1 and E3 will be equal. What about E2? E2 will not be equal to E1 and E3 because even though the charge is same, the distance will be different. E diagonal, the distance 2 centimeter irangilla. It will not be 2 centimeter. Right? Okay, that's why E2 will be different. E1 and E2 will be equal. E1 and E3 will be equal. Right? So you calculate E1 and E3 at a time. E1 equal to E3 is equal to, the formula is 1 divided by 4 pi epsilon naught Q divided by R square. So it will be 1 by 4 pi epsilon naught. The value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Don't forget it. Okay, into Q. Q means you have to take it as 4 nanocoulomb. 4 into 10 to the power minus 9 divided by the distance is 2 centimeter. I will take it in meter. 2 into 10 to the power minus 2 whole square. Okay. Calculation of bhalashtu jana mistakes ಮಾಡ್ತೀರಿ. In hurry you will make a silly mistake and you will lose the marks. So while solving numerical, 5 mark numerical, go step by step, go in detail, and with patience you have to solve it. You will be knowing the answers. You will be already happy after looking the numericals that okay, I can solve this. ಅದು ನಿಮಗೆ ಬಂದಿರ್ತದ್ರಿ, ಬಟ್ ಆ ಖುಷಿ ಒಳಗೆ ಅಥವಾ ಆ ಗಡ್ಬಡಿ ಒಳಗೆ ನೀವು ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಮಿಸ್ಟೇಕ್ ಮಾಡಿ ಮಾರ್ಕ್ಸ್ ಕಳ್ಕೊಂತೀರಿ. Right? So don't do that. With patience, you go in detail. Okay. So finally we will get E1 and E3 here. Okay, E1 and E3 we will get. Write the SI unit at any cost. Don't forget it. After that, you have to calculate E2 now. We have to calculate E2. Okay, the resultant of E1 and E3. So we got the values of E1 and E3. This is the direction of E3. This is the direction of E3 and this is the direction of E1. Since these both are equal and they are perpendicular to each other, these both are equal and they are perpendicular to each other, the resultant of these two vectors will be like this, exactly at the 45 degree. I will write that resultant as E31 or E13. Why I am taking this resultant E13 exactly at 45 degree? Because E1 and E3 both are equal. When these both will be equal, then only that 90 degree angle will get divided in 45 and 45. So first you calculate this E13. How to calculate E13? E13 is equal to root of T square plus Q square. Root of E1 square plus E3 square, right? Because they both are perpendicular. So here you will get E13 and write the SI unit Newton per coulomb. Okay, we got the resultant of E1 and E3. Okay, chalo, E1 is done, E3 is done. Next, we have to go for E2 now. Okay, how to find E2 now? E2 find ಮಾಡಬೇಕಾದ್ರೆ ಮೊದಲೇ ನೋಡ್ರಿ, E2 is the electric field due to plus 4 nanocoulomb charge and find the distance between them. ಈಗ distance ನೋಡ್ರಿ. ಈಗ ಇದು ಒಂದು ನೆನಪಿಟ್ಕೊಡ್ರಿ, whenever you get a numerical on the square, you remember this instead of sitting calculating. If x is the side of the square, if you want the length of the full diagonal, it will be root 2x. It will be root 2x. If you want half the diagonal means the distance from midpoint to the vertex. It will be x divided by root 2. Half the diagonal x by root 2, full diagonal x root 2, right? Okay. So here, how much will be this distance then? This distance will be x root 2. How much is x? X is 2 and root 2, right? This is in centimeter. Since this is in centimeter, this will be in centimeter. X root 2. Here x means it is 2 centimeter, right? Okay, that much will be the distance. Now you calculate E2. E2 means it will be 1 by 4 pi epsilon naught Q2. Q2 is 4 nanocoulomb, 4 into 10 to the power minus 9 divided by the distance. How much is the distance? Distance is root 2 centimeter. You take it in meter, 2 root 2 into 10 to the power minus 2 whole square. You have to simplify this. You will get E2. You will get E2, correct? In which direction E2 is there? See, E13 is in this direction. E13 is in this direction. Clear? This is E13. E13 and E2 both are in same direction. E13 and E2 both are in same direction. Therefore, the resultant electric field at the fourth corner will be equal to E13 plus E2. Resultant electric field at the fourth corner will be E13 plus E2. So you know the value of E13, you know the value of E2, add both of them, you will get the resultant electric field, Newton per Coulomb. Correct? So this is how we have to calculate the electric field at the fourth corner. If they ask you the electric field at the center, if the four charges are given, if they ask you the electric field at the center, you have to take these distances, half diagonal distance you have to take, right? And then you have to mark the electric fields at all that point. If the electric fields are in opposite direction, subtract them. If they're in same direction, add them, right? Like this we have to solve it. Okay, that's all about the numericals on electric charges and fields. Next we'll go for numericals on electric potential and capacitance. See, many times this type of question has been asked on work done. ABCD is a square of side 1 meter. Charges of plus 3 nanocoulomb, minus 5 nanocoulomb and plus 3 nanocoulomb are placed at the corners A, B and C respectively. Calculate the work done in transferring a charge of 12 microcoulomb from D to the point of intersection of diagonals. Okay. See, let us take a square here now. Okay. So ABCD is a square. Right, this is the square. I will name this square as A, B, C and D. Okay, they have placed plus 3 nanocoulomb at A, plus 3 nanocoulomb at A, minus 5 nanocoulomb at C at B and plus 3 nanocoulomb at C. Right, these are the charges that have been placed at the corners A, B, C respectively. Respectively under andmele 3 nanocoulomb A ಒಳಗೆ ಇರಬೇಕು, minus 5 B ಒಳಗೆ ಇರಬೇಕು, plus 3 C ಒಳಗೆ ಇರಬೇಕು. Calculate the work done in transferring a charge of 12 microcoulomb from D. Okay, ille ಒಂದು 12 microcoulomb charge ಇದೆ. 12 microcoulomb charge ಇದೆ from D to the point of intersection of diagonals. Okay, so let me draw the diagonals here. So we'll draw the diagonals here. Right? Okay, this is one diagonal and this is another diagonal. So these are the diagonals. Let me call that point of intersection as O. We want to move this 12 microcoulomb charge from D to O. We want to move this 12 microcoulomb charge from D to O. So we have to calculate how much will be the work done in moving this charge. How much will be the work done in moving this charge? Very first thing is, to calculate work done, we know very well, potential means it will be work done per unit charge. So work done means it will be equal to potential into charge, or potential difference into charge. Since you are moving the charge from D to O, final point is O, initial point is D. That's why here I have to take the potential difference between O and D, right? It means I have to take it as potential at point O minus potential at point D into the charge Q, right? So this is how, by using this formula, we'll calculate the work done. So very first thing what you have to do is you have to calculate potential at O as well as potential at D. So how to calculate potential at O now? Midpoint. See, a side of the square, I guess they have not given the side of the square placed at, okay, side of the square, okay, it is given 1 meter. Side of the square is 1 meter. Since all sides will be same, it is a square, right? Okay. How much will be the distance from center of the square to the corner of the square? It will be x by root 2. X by root 2, x is 1. So 1 divided by root 2 meter. This much will be the distance from center of the square to the corner of the square, right? So while calculating potential at O, you have to take this distance. How many potentials will be at point O? Since there are three charges, see, you should not consider this because we are moving this charge from D to O. It is not a static charge. Moving charge ada adanu consider madongiಲ್ಲ. Static charges ಏನದಾವ ಅದರದ್ದು ಮಾತ್ರ electric field ಮತ್ತು potentials ಗಳನ್ನು ನೀವು ತಗೋಬೇಕು. So electric potential at point O will be due to the charge at A plus charge at B plus charge at C. Correct? So ಎಲ್ಲ ಚಾರ್ಜಸ್ ಎಲ್ಲದರದ್ದು ಫಾರ್ಮುಲಾ ಒಳಗೆ ನಮಗೆ 1/4 pi epsilon naught ಕಾಮನ್ ಬರ್ತದ್ರಿ, ರೈಟ್? ಸೊ ಇಟ್ ವಿಲ್ ಬಿ ಚಾರ್ಜ್ at A divided by OA plus charge at B divided by OB plus charge at C divided by OC. Correct? So this will be 9 into 10 to the power 9. You know this very well, right? Okay. See, all these distances OA, OB, OC are same. OA, OB, OC are same. It will be 1 by root 2. So I will take this common. It will come outside. It will be 1 by root 2. In the bracket, I will get QA plus QB plus QC. Among this, one charge is negative. Charge at B is negative. So you have to take it, while substituting the charge, you take it as minus. Okay, here you substitute plus 3, here you substitute minus 5 nanocoulomb, here you substitute plus 3 nanocoulomb. In potential, you have to take the polarities. In force and field, you don't take the polarities. You just put the directions on the basis of the polarities, right? So by using this formula, we will get a VO. Okay, here I will get a VO, it will be in volts. Similarly, calculate VD. Calculate VD. See, while calculating VD, at D also there will be three potentials. One is due to plus 3 nanocoulomb, minus 5 nanocoulomb, plus 3 nanocoulomb, right? So here again you have to take three potentials: potential due to the charge at A, potential due to the charge at B, plus potential due to the charge at C, right? Every formula contains 1/4 pi epsilon naught. I will take it common. In the bracket, I will get charge at A divided by OA plus charge at B divided by the distance is BD now. So this one difference we will get. ಇಲ್ಲಿ ನಮಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಮೂರು ಸೇಮ್ ಇರ್ತಾವ್ರಿ, ಇಲ್ಲಿ ಸೇಮ್ ಇರಂಗಿಲ್ಲ. ಇದು ಸೇಮ್ ಅದ, ಇದು 1 ಮೀಟರ್, ಇದು 1 ಮೀಟರ್ ಸೇಮ್ ಅದ, ಬಟ್ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಬೇರೆ ಆಗ್ತದೆ. ಫುಲ್ ಡಯಾಗೋನಲ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್. Full diagonal means x root 2. How much is x? X is 1. 1 into root 2. This much distance we have to take, QB, for B charge. And for charge at C, again the distance is OC, that is 1 meter. So here you cannot take common in the numerator, right? Again you substitute value of QA 3 nanocoulomb, value of QB minus 5 nanocoulomb. You put minus, so this sign will become minus. Here also this sign will become minus. And you put plus 3 nanocoulomb here, right? This is 1 meter, this is 1 meter, this is 1 root 2 meter. Go on simplifying, you will get the potential at D. Right? So finally, after getting the potential at O and potential at D, substitute the values of O and VO and VD here. Substitute the values of VO and VD here, as well as substitute the value of charge. How much is the charge which we are moving? That is 12 microcoulomb. 12 into 10 to the power minus 6. Simplify this, you will get the work done, and work done will be in joule, right? So this is how we have to calculate the work done. We'll go for the next question. Next question is, charges 2 microcoulomb, 4 microcoulomb and 6 microcoulomb are placed at three corners ABC respectively of a square ABCD of side x meter. Okay. Find what charge must be placed at the corner D such that the potential at the center of the square is 0. Okay. Well, so it is a square now. Detailed solution bekadra videos link in the description or siktava, even numericals adava. I solved them already. You can check it there. Okay. So this is ABCD. ABCD is the square. Okay, here we have placed 2 microcoulomb charge, here we have placed 4 microcoulomb charge, here we have placed 6 microcoulomb charge, and placed at three corners ABC of respectively. Side of the square is x meter. Okay, x meter, side of the square. Find what charge must be placed at the corner D. Okay, what charge must be placed at corner D such that the potential at the center of the square is 0. Okay, center of the square ಒಳಗೆ ನಮಗೆ potential 0 ಆಗಬೇಕಾಗಿದೆ, right? Okay, center of the square means where the diagonals will meet. That is the center of the square. Okay, so the center of the square means where the diagonals will meet. So here this point is the center of the square. I will name it as O. See, somewhat we don't know how much charge is here. There is a charge at point D, right? And we don't know the value of that charge. ಈ ಚಾರ್ಜ್ ಇಲ್ಲಿ ಇಟ್ಟಿದ ಕೂಡಲೇ ನಮಗೆ ಸೆಂಟರ್ ಒಳಗೆ ನೆಟ್ ಪೊಟೆನ್ಷಿಯಲ್ 0 ಆಗಬೇಕು, ಕರೆಕ್ಟ್? ಈಗ ನೋಡ್ರಿ, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಪಾಸಿಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್, ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್. Since there are three positive charges here, ಈ ಮೂರು ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಪೊಟೆನ್ಷಿಯಲ್ ಸೆಂಟರ್ ಓ ಒಳಗೆ ಎಷ್ಟಾಗ್ತದೆ ಅಷ್ಟ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ನಮಗೆ ಈ ಚಾರ್ಜ್ ದಿಂದ ಸಿಗಬೇಕು. ಸೊ ದಟ್ ಈ ಚಾರ್ಜ್ ನೆಗೆಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಮತ್ತೆ ಈ ಮೂರು ಚಾರ್ಜ್ ಪಾಸಿಟಿವ್ ಪೊಟೆನ್ಷಿಯಲ್ ಕ್ಯಾನ್ಸಲ್ ಔಟ್ ಆಗಿ ನೆಟ್ ಪೊಟೆನ್ಷಿಯಲ್ ನಮಗೆ 0 ಆಗಬೇಕು. ಸೊ ಆನ್ಸರ್ ಇಸ್ ರೈಟ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ಯುವರ್ ಐ. 6 plus 4 12, 12 plus 6 plus 4 10, 10 plus 2 12. It means 12 volt. Let me say somewhat 12 microcoulomb charge the positive potential illade. Hangadre ee charge ಎಷ್ಟು ಇರಬೇಕು -12 microcoulomb ಇರಬೇಕು. Then only the potentials will be same, they will get cancelled. That we have to calculate what by formula here. Okay, so the distance from the center to the corner will be x by root 2. So this is x by root 2, this is x by root 2, this is x by root 2. The distance of all the charges from the center is same, x by root 2. So the potential at point O will be due to the potential of charge at point A, due to the potential at charge at point B, point C and point D, right? At the center, how much the potential has to be? It has to be 0. So then 0 anta itkonbidu. Ivella formulas olaga namagu 1 by 4 pi epsilon naught common iruttade. What is the formula of potential of a point charge? It is 1 by 4 pi epsilon naught q divided by r, right? So here I will take 1 by 4 pi epsilon naught in the bracket. Charge at point A divided by x by root 2 plus charge at point B due to charge at point B divided by x by root 2 plus charge at point C divided by x by root 2 plus charge at point D divided by x by root 2. Correct? So this much we will get. Now what we have to do is x by root 2 will be common. So this will be 0. You do 9 into 10 to the power 9 and divided by x by root 2 divided by x by root 2 into the bracket qa plus qb plus qc plus qd. So and so we'll get, right? X by root 2 ನೀವು ಈ ಕಡೆ ತಗೊಂಡ್ರೆ 0 ಆಯ್ತು, ಇದು ಕಂಪ್ಲೀಟ್ಲಿ ನಮಗೆ 0 ಆಗಿಬಿಡ್ತದೆ. So 0 is equal to qa plus qb plus qc plus qd, right? So a plus b plus d, sorry, a plus b plus c, 2 plus 4 6, 6 plus 6 12. So this will be 12 plus qd. So qd is equal to ನಾವೇನಾದರೂ ಬರ್ಕೊಂಡ್ರೆ, if we write qd is equal to, it will be -12 microcoulomb. This much will be the charge that we have to place at point D to get 0 potential at the center. Okay, we'll go to the next question then. 2 point charges 1 microcoulomb and -4 microcoulomb and are 1 meter apart in air. Find the positions along the line joining the two charges at which the resultant potential is 0. Okay, there are two charges here. One is 1 microcoulomb and the other one is -4 microcoulomb, which have been placed at a distance of 1 meter in air, right? I'm going a bit fast because this is one shot video, and you all, I guess you all know, you all have a very good grip on the numericals. It may help you as a fast revision video. Okay, well, so here we are having two charges now. One is 1 microcoulomb, let me say it is here, plus 1 microcoulomb charge, and another one is -4 microcoulomb charge, and they have been placed at a distance of 1 meter. They have been placed at a distance of 1 meter in air, right? 1 meter in air. Find the positions along the line joining the two charges at which the resultant potential is 0. So how many points will be there where the resultant potential will be 0 for system of two charges? For system of two charges, there will be 3 points at which the potential will be 0. One, it will be in between the charges. First 0 potential point will be in between the charges. One will be outside the charges and one will be at infinity, right? Infinity olagantu potential 0 irutte. So let me say the first point is here. I will call this as P, and the second point is here. And this 0 potential point will be almost close to the smallest charge, plus 1 microcoulomb. It is bigger in magnitude, it is smaller in magnitude. I will call this as Q. Let me say the distance of the point P is x from plus 1 microcoulomb. Okay. So first let us find point P, right? Model point P now find madam. Idan amel togolona. First let us find the point which is in between the charges. In between the charges, x we have to find. If this is x, how much will be this? This will be 1 minus x meter, correct? So point P olaga namaga net potential 0 agಬೇಕಾಗಿದೆ. So net potential has to be 0. How many potentials will be at point P? There will be two potentials. One is due to plus 1 microcoulomb, one is due to -4 microcoulomb. So I will call it as V1 plus V2. V1, this is V1 plus V2. V2 is negative since it is, right? Since it is due to negative charge, right? So in net potential namaga 0 agಬೇಕು. What does it mean? It means that V1 will be equal to V2. So remember, if there is a system of two charges at a point where the net potential is 0, at that point potential due to both the charges will be same. It means you can directly take V1 is equal to V2 at that 0 potential point. Okay, well, so V1, it is potential due to 1 microcoulomb, V2 it is potential due to minus 4 microcoulomb. We have already taken the minus sign here, so don't substitute one more minus sign again when you are substituting the value of charge here. Once you substitute minus, that's over. Otherwise, if you don't substitute here, while putting the charge you substitute minus, that will be okay. Okay, well, so the formula for point charge is 1 by 4 pi epsilon naught q divided by r1, q1 divided by r1, and this will be 1 by 4 pi epsilon naught q2 divided by r2. 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled. Q1 means you should take it as 1 microcoulomb, r1 means you should take it as x, q2 means you should take it as 4 microcoulombs. So I will just substitute here 1 into 10 to the power minus 6 divided by x equal to 4 into 10 to the power minus 6. Again, don't take minus here because we have already taken minus here, and the distance is 1 minus x, right? Micro will get cancelled, cross multiply, you will get the value of x. So we got the value of x, right? It has to be in meter. We'll get the final answer. So that is the 0 potential point in between the charges. Outside the charges, okay, let me say outside the charges, here is the point. That point I will call it as q, and let me take this distance as x now. Let me take this distance as x. Okay, so this is the first 0 point, 0 potential point. Second 0 potential point we have to take now. So 0 potential point andre a potential q enada, sorry, point q enada a point olaga there will be a potential due to plus 1 microcoulomb also and minus 4 microcoulomb. Itradu potential illi irtade, itradu potential illi irtade, and they both has to be equal. Then only they will get cancelled and net potential will become 0. So I will take V1 is equal to V2 at that point q. So V1 will be 1 by 4 pi epsilon naught and Q1 divided by, what is the distance of Q1? X. Q1 divided by X. V2, 1 divided by 4 pi epsilon naught. Q2 divided by, what is the distance now? Distance is 1 meter plus X. So this distance you have to take now. You have to take this distance. This distance you have to take. That is 1 plus X or X plus 1. Right? So this distance you have to take 1 plus X. So 1 by 4 will get cancelled. Substitute the values of Q1 and Q2. Cross multiply, you will get the value of x, right? This has to be in meter. This is how we have to calculate that point. Well, we'll go to the next question then. Okay, now these questions are on capacitor. See, in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3. This is power minus 3 meter square. That is meter square, m2 alla meter square, and the distance between the plates is 3 mm. Calculate the capacitance of the capacitor. If this capacitor is connected to 100 volt supply, what is the charge on each plate of the capacitor? Okay, well, see, parallel plate capacitor with air between the plates. Each plate has an area. Area they have given, area is 6 into 10 to the power minus 3 meter square. This much is the area. Distance between the plates is 3 mm. I will take the distance as 3 millimeter. Millimeter antandre adanna meter olaga barkotini. 3 into 10 to the power minus 3 meter. Calculate the capacitance of the capacitor. Capacitance we have to calculate. And what if the capacitor is connected to a battery of 100 volt? To a battery of 100 volt. What is the charge on each plate? So we have to calculate the charge on each plate. Okay. Well, first let us calculate capacitance. Capacitance of a parallel plate capacitor is given by C is equal to epsilon naught A divided by D. Right? What is the value of epsilon naught? It is given here. It is 10 to the power minus 12. So it will be 8.85 into 10 to the power minus 12. How much they will give? That much only you use. Don't use extra digits here. Okay. Area is given 6 into 10 to the power minus 3. 6 into 10 to the power minus 3 divided by distance 3 into 10 to the power minus 3. 3 into 10 to the power minus 3, right? So you have to multiply this and you will get the capacitance, and that capacitance will be in farad, and if you remove 10 to the power minus 6, you keep it in microfarad. So and so, right? I'll new 10 to the power basis mele new unit it go right? Capacitance. We got the capacitance now. Next, we have to calculate charge on each plate of the capacitor. See, we know this very well. C is equal to Q by V. C is equal to Q by V, right? So next, we want what charge we want. So Q is equal to, I will get it as C into V. Q is equal to C into V. C means you take this capacitance. V means it is given 100 volt. Substitute, you will get the charge. Either this charge will be in coulomb or it will be in microcoulomb. If this is in microfarad, this will be in microcoulomb, right? This is how we have to calculate it. Okay, we'll go for the probably the last question. Okay. All those questions have been already solved and they are present in the video. You can watch that video for the detailed solution. This question is not been solved there. I will just tell you the method how to solve it, right? Okay, two capacitors of capacitance 2 microfarad and 8 microfarad are connected in series, okay, and the resulting combination is connected across a 300 volt battery. Calculate the charge, comma, potential difference and the energy stored in each capacitor. So there are two capacitors now which are connected in series. So like this, we are having two capacitors in series, right? The two capacitors are connected in series. This is of 2 microfarad. I will call this as C1, and this is of 8 microfarad. I will call it as C2. Okay, after that, the resulting combination is connected in series, right? Okay, it is connected in series, and the resulting combination is connected across 300 volt battery. So 300 volt battery, 300 volt battery. Calculate the charge. Okay, we have to calculate the charge on each capacitor and potential difference of potential difference and the energy stored in each capacitor. Okay, these three things we have to calculate. Okay, ignore it. Since these both are in series, first calculate the effective capacitance. Effective capacitance find madlike, we have the formula C1 into C2 divided by C1 plus C2 will get the effective capacitance. This effective capacitance will be in microfarad, right? Microfarad. Next, we have to calculate charge as well as potential difference. Series ಒಳಗೆ ನಮಗೆ charge same ಇರ್ತದೆ. Charge on both the capacitors will be same, right? Potential difference will get divided. Series ಒಳಗೆ potential difference divide ಆಗ್ತದೆ. Parallel ಒಳಗೆ charge divide ಆಗ್ತದೆ, potential difference will be same. So the potential difference across this will be V1, across this will be V2. That is what we have to calculate, right? But charge on both the capacitors will be same because this is a series combination. Okay. So to calculate the charge, since we know C is equal to Q divided by V, right? Here I will take the effective capacitance. If you want the charge, you will apply it. You can change the formula like this: Q is equal to CS into V. How much is V? V is 300 volt. You substitute that here. CS you substitute here. You will get the charge, which will be in microcoulomb, and the same charge will be on first capacitor also, second capacitor also. So we got the charge. Okay, here is the charge. It is given 4.8 into 10 to the power minus 4. This is power minus 4 coulomb, right? Answers are here. Ill answers are the answers not both. Charge is same on both the capacitors. Charge will be same. Potential, note potential ನಮಗೆ 240 ಮತ್ತು 60 ವೋಲ್ಟ್ ಅಂತ ಹೇಳಿ ಎರಡು potentials ಕೊಟ್ಟಿದ್ದಾರೆ. ಯಾಕಂದ್ರೆ potential differences ಬೇರೆ ಬೇರೆ ಇರ್ತವೆ. So to calculate the potential difference on the first capacitor, you use this C1 is equal to Q divided by V1. You want V1, so V1 is equal to Q divided by C1. Q you have already got, C1 is already given, you will get V1. Similarly, V2 calculate ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ Q divided by C2. You will get V1 in volts and V2 in volts. How much they are? They are 240 and 60. Similarly, you have to calculate energy of both the capacitors. No? U1 is equal to half C1 into V1 square. U2 is equal to half C2 into V2 square, right? So C1, C2 are given, V1, V2 you will get here, substitute them, you will get the energies, right? So will energies go together. This is 10 to the power minus 2, this also 10 to the power minus 2 joule, right? So these energies will be in joule. This is how you have to calculate the energies, right? So that is all about the 5-mark numerical problems on electric charges and fields as well as electric potential and capacitance. Dear students, if you have not subscribed the channel and if you like the content of this channel, please don't forget to hit the subscribe button and please share this video, share the channel with your friends. Please keep watching and supporting this channel. Thank you so much. If you need anything else, please put a comment in the comment box. We'll be there with the video in the next session, right? Thank you. We'll meet again in the next video. Please go through and study well for your physics exam and do great in your physics examination, right? Whatever support you need, I will be here as much as possible. Apart from all my offline schedule, I am trying to make the videos and upload for you all. So please don't forget to subscribe and share the video, right? Thank you so much. We'll meet again in the next video.